So basically, this question was asked in GATE exam. Basically, in the physics, GATE physics 2024. The question basically comes in the nuclear physics section, right? Radioactivity decay process related to radioactive uh, decay process, right? So the question is, let Ne, right? So Ne be the Ne and De denotes the number and kinetic energy of electrons produced in the nuclear beta decay process. So which one of the following distribution is correct, right? So basically, when you want to solve this, right? So Ne is basically, so Ne is a number of, right? So the number of electrons, right? Electrons released in the beta decay process, right? So that basically what we have to know here is, so there is some beta decay process, there is a beta decay process. So beta decay, so beta decay process, there is some beta decay process. During that beta decay process, what happens, some electrons are ejected, right? So the electrons are ejected, so electrons are ejected, right? The electrons are ejected, and that electrons number is Ne, right? The number of electrons is Ne. And similarly, this electrons kinetic energy, right? The kinetic energy is Te. The kinetic energy of electron is Te. So then what we have is, right? So what we have is, so then they started drawing the graph, right? Then started drawing the graph, uh, uh, Ne in the y-axis, right? Ne in the y-axis, and Te in the x-axis. So that means number of ejected electrons in the y-axis, and the kinetic energy of the electrons in the x-axis. So if they draw this number of electrons in the y-axis and kinetic energy of electron in the x-axis, so what will be the nature of the distribution function, right? So that's what we have to identify or find out. Basically, this is a beta decay process, right? Beta decay process, and during that beta decay process, right, electrons are ejected. It mentioned that the electrons are produced, right? Electrons are produced. So in that decay process, electrons are produced, and then that electrons produced electrons coming with some kinetic energy. That kinetic energy is Te. So how many number of electron ejected? That is Ne, right? That is Ne. So now, before going to before identifying, or before finding out which is the right answer, so let us discuss about this decay process. Then we will, from that discussion, we will identify which one is the right option or right answer. So actually speaking, there are two types of beta decay process: beta minus decay process, right? So decay process. The second one is the beta plus decay process, right? Decay process. So actually, in the beta minus decay process, electrons are ejected, and beta plus decay process, positrons are ejected. So since in our case the electrons are ejected, right, we will look at this beta minus decay process. Then there we will write the beta minus decay process mechanism. Then from that we will discuss the, or identify the right answer or distribution of these. So in the beta minus decay process, right, the beta minus decay process, so one neutron will be converted into one proton plus electron, right? Electron plus some antineutrino will be released. So this equation can also be written as, that is 1 H1 plus E minus 1 0 plus antineutrino, right? Antineutrino. So this can be written in this way also, right? Nu bar. So when you look at the distribution function for the number of electrons ejected with versus the kinetic energy of those electrons, so that comes in the following way, that follows the trend in this way. So if you draw the y-axis is number of electrons in the y-axis, and kinetic energy of electron in the x-axis. So the distribution initially increases and then falls off, and then falls off. So here, as we already noted, or we know that this is the number of, right? So the number of electrons ejected, the number of electrons ejected, and their kinetic energy in the y-axis, x-axis. So the point where it touches the x-axis in this distribution, we call it as the end point energy. End point energy. So at this point, the kinetic energy, right? Kinetic energy of electron is maximum. The kinetic energy of electron is maximum. So therefore, so what we can do is, we can just say that in this case, if you look at the distribution function, that is something like this, right? So this initially increases and falls off. This is the trend of the number of ejected electrons versus the kinetic energy of those ejected electrons. So from this figure, right, so we can say that the option C, right, the option C is the right answer, right? So it just initially increases, then falls off. This is the trend. So therefore, for this question, the right answer is C.